Hello everybody, welcome to my YouTube channel, and in today's video we are going to solve the numerical problem of decision trees. So this is the problem statement which we are going to consider to solve the problem of decision tree. So when we talk of decision tree algorithms, here we need to calculate the gain for each and every attribute. So here in this example we can say we are having total 14 records, and we are having total 1 2 3 4 attributes in this case. That on the basis of these 4 attributes, the decision is taken whether someone will play tennis or not. Like in the first, it is saying that if the outlook is sunny, temperature is hot, humidity is high, wind is weak, and in that case it will play tennis. Similarly, for day 4, if the outlook is rain, temperature is mild, humidity is high, wind is strong, then tennis will be played in this case. So this is the problem statement as we have done in the naive Bayes algorithm also. Same example we are continuing, but we will create or draw a decision tree in this case. So for before proceeding further, if you have not watched the previous video on entropy and information gain, just go through that video once, because you should know how to calculate entropy and information gain before solving this numerical problem, because in this case we will be using. Now let's see what we need to do in this case. So here this is my attribute, and this attribute is nothing else. This attribute is simply my categorical variable on which we have to make the decision, means we will be classifying accordingly. And these are the 4 attributes. We will pick each and every attribute one by one. Firstly, we will pick outlook attribute, and then we will pick temperature, humidity, and wind, and so on. Now when we solve this problem, firstly we will take the outlook attribute and we will calculate the entropy for sunny, then we will calculate the entropy for overcast, then for entropy for rain. So we will calculate these 3 entropies, and based on these 3 attributes entropy, we will calculate the information gain for outlook. Similarly, after that we will proceed with attribute temperature, and in temperature attribute we can see we are having values hot, mild, and cool. So 3 entropies will be calculated, and using these 3 entropies we will calculate the information gain for temperature. Similarly, for humidity we can see we are having 2 values, high and normal. So we will calculate entropies for both high and normal, and using these 2 entropies we will calculate the information gain for humidity. Similarly, for wind the values are weak, strong, weak and strong only. So we will calculate 2 entropies, and using these 2 entropies we will calculate the information gain for wind. So what we are doing, we are calculating the information gain for all these 4, and if whatever is the attribute which is having the highest information gain, that will be chosen as the parent node. Fine. So we will start solving the problem now, and then meanwhile proceeding we will continue with the next steps. Fine. So let's proceed. Okay, so we have already discussed the formula for calculating the entropy. So just let's first consider the attribute. We will calculate use the attribute outlook. This is my very first attribute for outlook. Now we have got the value for this case. Value will become outlook, and these values are sunny, overcast, and rain, as we can see in this here, sunny, overcast, and rain. So we have got these 3 values. Now we will calculate this. So before proceeding further, we will calculate the general entropy, that is the mean entropy. We can call it entropy of S. Now when we calculate the entropy of S, we will have a look at this. For entropy for this complete table, we are having 1, 2, 3, 4, 5, 6, 7, 8, 9 yes, and we are having 5 values for no. It means 9 positive and 5 negative values. So what we will note over here, we will say this is for 9 plus 5 minus. Now this entropy of S, how we will calculate? Minus, we know, positive values divided by total values. So as we can see in this example, we are having total 14 records. So total number of records are 14. So it will be minus 9 oblique 14 log 2 9 oblique 14. Then put the sign of minus. Now calculate the entropy for this 5. That is minus 5 oblique 14 log 2 5 oblique 14. Now when we will solve this problem, we will get 0.94. So we have got that entropy of S is equal to 0.94. This is the general entropy in our case. Fine. Now once the general entropy is calculated, what is the next step? We will calculate, we have to calculate the information gain for each and every attribute. So we are starting with the attribute outlook. In this case, we are having 3 values. So we will calculate the entropy of all the 3 values. Fine. So for this, what we need to note down, we know one value was sunny. So we will calculate the entropy for sunny. For sunny, we are having how many yes and how many no. So when the value is sunny, these are sunny, 5 values for sunny, and in this case 1, 2, 2 are negative, 3 are negative values, and for sunny we are having 1 and 2 yes values, means positive values. So positive and negative ratio we get, here we got 2 plus 2 positive values and 3 minus, that is 3 negative values. So total values for sunny in this case we are having 5. So putting these values into the formula, that is entropy of, not only yes, this is entropy of sunny in outlook. So it will be minus 2 oblique 5 total values log 2 oblique 5 minus 3 oblique 5 log 2 3 oblique 5, and here by solving this we will get 0.971. Now next value for entropy we have for entropy of S overcast. Now when we talk of overcast, so if we have a look at this, when we are having this overcast value, overcast 4 values are there for overcast, and for these 4 we are having here and here all the yes values. So 4 yes and 0 no. So here how can we write? We write it like this, 4 plus 0 minus. Now here is one important thing that we need to note. So when we calculate entropy, and if we are calculating the entropy for 1 plus 1 minus, or 2 plus 2 minus, or 15 plus 15 minus, it means equal number of positive and equal number of negative cases, then we need not to put the values in formula. Here we will simply declare that the entropy is 1 in this case. So this is that entropy when we have equal ratio of positive and negative. Now another example that we need to note, like in this case, if any value either negative or positive is having 0 count, it may be for 0 may be for positive or 0 may be for negative. In that case, means we can say simply positive and 0 negative, or we can say 0 positive or n number of negative values. In such case, if any value comes to be 0, then in that case entropy we need not to calculate, we have entropy value as 0. So here we can say 4 positive but 0 negative. So in this case the entropy will be 0. Similarly, we calculate the entropy for the next value. So next, as we can see in this example, next is for rain. So we calculate for rain. So we calculate for rain. So how to calculate for rain? So we are calculating entropy for S rain. And when we talk of S rain, so in this case we have 3 plus and 2 minus. Let's have a look at here. So when we talk of rain, we are having play 10 is 3 yes and 2 negative values. So for this when we put the values in the formula for the entropy, we get minus 3 oblique 5 log 2 3 oblique 5 minus 2 oblique 5 log 2 2 oblique 5. So when we solve this problem, we get 0.971. So in the outlook, we were having 3 sunny, overcast and rain. So we have calculated entropy for sunny, overcast and rain in this case. Now we will calculate the information gain. Fine. So we will calculate information gain now. Fine. So to calculate information gain, we are calculating gain for S comma outlook. So what is the formula? We know entropy of S minus sigma S of B oblique S entropy of SB, where B belongs to which values? We have sunny, we have overcast and we have rain. So now we know that we have calculated this value, which was 0.94 minus. So here we will put firstly for sunny, then for overcast and then for rain. So as we can see in this, for sunny we are having total 5 values, and total number of values, that is S common S, that was for centralized, we are having 14. Similarly, when we look at overcast, we are having 4 values for overcast and total values are 14 in this case again. And for rain we are having 1, 2, 3, 4, 5 values for rain and total values will remain 14, that will go into denominator. So we will take the sum of all this value and will solve the problem in this case. So it will be, for sunny there were 5 into entropy of S sunny minus, for overcast we have seen that was 4. So we will do entropy of S overcast minus 5 oblique 14 entropy of, in this case, S for rain. So when we solve this, when we put the values, we will get for this 0.94 minus 5 oblique 14, here we were having plus, sorry, for in this case entropy of S into sunny was 0.971 minus 4 oblique 14, entropy for overcast was 0, we have calculated, into 5 oblique plus 5 oblique 14 into 0.971, and we will get here the value 0.2464. So this is basically the gain in case of outlook. Fine. So as we can see, we have got the gain for this. So what was the gain in this case? 0.2464. This is the gain for this value. So further proceeding, we will calculate the gain for temperature. So for calculating the gain for temperature, we will again repeat all the steps. We will calculate the entropy for hot, mild and cool, and taking the sum of all these values along with the their product with the entropies. We will subtract that from the common value of entropy, that is entropy of S, and we will get the information gain for this. So let's quickly have a look at this, how to solve this. So I have already solved this. So we will, rather than typing, we will have a quick look at this. This is what we have done till now. We have got the this thing. Now what is to be done in the next case? So we have to calculate the information gain, which is positive by n. Fine. That is positive by n, log to positive by n, and so on. So this is how we calculate information gain. Now next attribute is temperature. So in temperature we have seen the values are hot, cold and mild. So when we talk of hot, cold and mild, the entropy will remain, the mean entropy of S will remain same, that is 0.94 already calculated. Now when we calculate for S of hot, so when we have a look at this, for S of hot we are having, for hot values we are having how many? Yes, for that case we will have a look at the positive and negative values. So when we look at this case, we are having basically for temperature we are having 2 yes and 2 no. So we will calculate that. So you can see 2 plus 2 minus. So similarly putting the values in the same formula, minus 2 oblique 4 log to 2 oblique 4 2 oblique 4 9 2, and we will get here the entropy, that is 1.0. Fine. So proceeding further, in this case equal to occurrence of entropy of 1, because we are having equal cases 2 plus 2 minus. So if you don't want to put any values in this case, you need not to put, because in this case the entropy will remain 1. Similarly we calculate for S of cold, for 3 where 3 plus are there and 1 minus is there for cold. We will put the values in this formula and get the entropy for cold. Similarly for S mild, using this we will calculate the entropy for this. Now we have calculated entropy for all the 3 values, for entropy for hot, mild and cold. Now based on this we will calculate the information gain. So putting the values in the information gain for all this was the entropy of S 0.94 minus 4 oblique 14 into entropy of S hot minus 6 oblique 14 entropy of S mild minus 4 upon 14 entropy of S cool. So these 3 values we have calculated over here. Fine. So we will simply put these values over here and we will get the gain in this case for temperature is 0.0289. So put it over here, that is 0.0289 for this case. We will repeat the same steps for humidity. We will calculate entropy of high, normal, these 2 entropies, and based on those 2 entropies and entropy of S, we will calculate the occurrence of for humidity. Fine. So just a minute. So we can see over here. So for S of high, when we take the attribute of humidity, so 3 positive is there, 4 negative is there, we will calculate, we will get 0.9852. Then similarly for S of normal, we will calculate the entropy, and based on this entropy we will calculate the gain for this humidity. So putting this value, we will get the information gain in this case, that is 0.1516. We are repeating the steps as 0.1516. So here we got 0.0156. Likewise, similar steps we will repeat to calculate the information gain for wind. Here we will calculate the entropy for weak and strong, and after calculating that entropy we will calculate the information gain for wind. So repeating the same steps, values are strong and weak, we will calculate for S of strong, where 3 plus and 3 negative, that is 3 yes and 3 no are there, so entropy will remain 1, we need not to calculate. And here when weak 6 plus and 2 minus is there, we will calculate the entropy. In this case we will get 0.8113. So using these entropies, calculate the gain for wind, and we will get 0.0478. So here we got 0.0478. So we have calculated the information gain for all those 4 parameters. So when we calculate the gain for all these 4 attributes, now we will find the maximum gain. So maximum gain is outlook. So it will give us a decision that my parent node will become outlook, and we will start accordingly. Fine. So highest information gain is with out. So fine, we can see. Just give me, okay. So we know that the outlook is having the highest gain, where 9 positive for outlook we are having 9 yes and 5 no for the main. So outlook is having, here we know, sunny, overcast and rain. So 3 branches will come out. So these are the 3 branches for sunny, overcast and rain. So when we look at this sunny, for sunny we were having 2 yes and 3 no. For overcast we were having 4 yes and 0 no. For rain we were having 3 plus and 2 no's. Now when we have a look at this is giving a clear decision. There is no chance of getting the no in this case. So we will declare that when the outlook is overcast, tennis will be played. Answer will be returned as yes. But when we look at these two attributes which says when the outlook is sunny or the outlook is rain, then in that case we have a question mark. We can't decide whether the answer will come to be yes or whether the answer will come to no in this case. Now let's have a look at this. When we are having sunny values over here, 1, 2, 3, 4, 5 sunny was there. So when we talk of these 5 sunnies, the rows were D1, D2, D8, D9 and D11. So we will now split this table into a subpart because we have already decided this outlook as the parent node. So this will be discarded for the further solution. When we design the subtree, we know outlook has already been declared as the parent node because it was having the information given from all those 4 attributes. So it is declared as the main parent. So now in the further decisions, while talking about the subtrees, the parent will not be included because the parent can't parent can't itself be a subtree node. Fine. So similarly, we for overcast we need to discard it. Why so? Because we have already decided all were yes. So when it is overcast, then the result will always be yes. So no need to work on this also. So next is we have confusion stage in rain as well. So when we talk of rain, we are having D4, D5, D6, D10 and D14. So we will pick these attributes for further expansion of a decision tree. So when we look at this, for sunny case, we are having these attributes. I have already shown you how these five attributes are there, and these are for rain. For overcast, we need not to expand further. Now, based on these columns, these rows and these rows, we will split the main matrix or table into 2 subparts. So now in this case, when we talk of sunny, then these values are there that are to be taken. All the attributes were taken, but not overcast because overcast has already been declared as a solution as a parent node. Okay, so here we will pick these rows with these columns. Now the problem has become shortened because we are building up a subtree for this. Now for this we will again find the values, or we call the information gain for all these. So we will calculate the information gain for temperature, information gain for humidity, information gain for wind. Before proceeding further, what we need to do, we will find the entropy of S for this table when it is sunny. So it means 3 no, 2 yes. We will calculate, and this will be known as entropy of S, where we are having 2 yes, 3 no's, and it will give the value for entropy, which will be like minus 2 oblique total are 5 log 2 oblique 5 minus 3 oblique 5 log 2 3 oblique 5. This will give me the entropy of S, my new entropy of S, because now I have to decide the parent node of the subtree. And we will, I am again repeating, we are not considering outlook in this case because outlook is the main parent. So now we will proceed for calculation of entropy or information gain for all these 3. We will repeat all the same steps. So when we talk of temperature, we will calculate it for the entropy for hot, entropy for mild and entropy for cool. So based on these 3 entropies, we will calculate information gain for temperature. Similarly for humidity, for high and normal, 2 entropies will be calculated, and based on those 2 entropies, we will calculate the information gain for humidity. Similarly, we will repeat the steps for wind. So while solving this problem, when we are considering the attribute 2, so when it is sunny, 2 3 minus, so we will calculate, we will get the information gain as this. Now when it is hot, temperature is hot, so in this case we say 0 plus 2 minus, so obviously entropy will be 0. Now this is case of 1 plus 1 minus, we know the entropy will be 1 in this case because the same case. And when it is cool, 1 plus 0 minus, so again the decision will be 0. So we have got entropy in one case, that is 1. Now we will use these 3 entropies and we will calculate the information gain for sunny. So 0.97, this is the mean entropy of S, minus 2/5 entropy of hot, minus 2/5 entropy of mild, and this. So these two values for cool and hot, it will give the 0, so will be discarded. So simply we can use this and entropy of this value. So putting this value 0.97, it will be cancelled out, it will become 0. So by solving with these two, we will get information gain for this. So I will upload these notes in the description box for your reference. This complete solution will be provided in the description box. So similarly for humidity, we will solve these problems 2 plus 3 minus. So we will calculate the same way. Here 0, 3 minus, entropy is 0. For normal, entropy is 0 in both the cases. This will be 0, 0. So obviously the mean entropy will give the answer in this case. So we calculate this 0.97. So gain in this case will be 0.97. Now similarly for the third attribute, which was the third attribute, as we can see, this is the wind. We have calculated information gain for temperature. For humidity, now we will calculate it for wind. So when we calculate this for wind in this case, we will get the information gain for this entropy for strong, 1 and 1, obviously it will be 1, no need to put the values in the formula. Now here 1 plus 2 minus, here we need to calculate using the formula. We will get the entropy in this case, and here we will calculate the gain for wind in this case. Now when we talk of calculating the gain, we will get this gain. Now we see when the value in this case, let me write quickly these values on the sub table here, so that we will get to know. So when we talk of temperature attribute, what was the information gain? In this case, the information gain was 0.0289, as we have calculated this value. Now when we talk of the case of humidity, so for humidity we have calculated that the information gain was 0.1516. Now when we talk of wind, we have calculated it as 0.0478. So now have a look which one is having the highest information gain. Humidity. It means after this, here we will decide it that my next parent will be humidity. Now based on this humidity, for humidity we are having high and normal. So two nodes will come from this. One will be for high, another one will be for normal. So based on this, have a quick look at this, how what type of solution we get. We get solution like this for high and normal. So for this we were having the value 0 and 0, no and yes, we have got that decision. It means we need not to expand it further. So we have this is known as pruning. This is done, this is done. We are left with this question mark value only, which is for rain. Now from this main table, here main table, now we will pick the values for rain. This one was for rain, this one, these two were for rain, 3 were for rain. So using these 5 values but not including outlook attribute, we will proceed further. Fine. So we will proceed with this subtree. Here we can see this is what we have done. Okay. So this is what we are having for temperature. So when we talk of this temperature, we are having these 5 rows. Now what we need to do in this case, for playing tennis, and main entropy will remain S of sunny in this case because rain in this case because we are expanding for the rain. So we will calculate information gain for temperature, for humidity and for wind using entropy of mild, cool, here high, normal, here weak and strong. So we will have a quick look how these are working. So for S of rain 2 plus, we will take the entropy 0.97. For S of hot, we can say 0 plus was there, 0 minus was there. So here, when we talk of temperature mild, so in case of mild, there was 1 no and 2 yes. When we talk of cool, 1 yes and 1 no. Similarly for humidity, for high, we are having 1 yes, 1 no. So entropy will become 1 in this case. Normal, 2 yes, 1 no. So based on those, we have calculated for these values using that sub table. We will expand it further. For attribute humidity, 3 plus 2 minus, it will become 0.7. So when it is high, we got 1.0. For normal, we get this. And now we will calculate the gain for this rain and humidity. So we got 0.192 in this case. We will proceed for the wind attribute. So for wind attribute, we are having strong and weak. So 0 plus 2 minus, so obviously entropy will be 0 because one of the value is 0. For weak, 3 plus 0 minus, obviously entropy will become 0 in this case. Now using these two entropies, we will calculate the information gain for no, for rain. So this is the formula and we will get this information gain no in this case. Now as we can see, for rain, the information gain is 0.92 for temperature case, and for rain, for humidity attribute, information gain is 0.192. For rain, when it is wind, the information gain is 0.97. So which is the highest? 0.97. It means from the attribute here, for this attribute, we will proceed with the highest value in this case. And we have already seen which one is the highest in this case. So based on that, we will expand. So we know that it is for wind. So it will be replaced with wind. Now what were the values for wind in this case? Wind is weak, wind is strong. So based on that, when the wind is weak, we were having 3 plus 0 minus. And when we talk of strong, we have 0 plus 2 no's. So this is a clear decision. So it says when the wind is weak, then play yes. When the wind is strong, play no. Now as we can see, all the nodes are expanded and we have got the solution at the leaf node. It means we have designed the complete tree in this case. So this is how we make a decision tree using entropy and information gain. So I hope you have got the idea to solve this numerical problem. So using this entropy and information gain, this is a very easy problem, very easy to understand. Only it is a bit tricky or bit lengthy, but without solving this you will not be able to decide which is going to be the root node. So if you have any doubt, you can write in the comment box. And if you have liked the video, then do subscribe to my channel and share it with others also. And also click on notification button so that for if I upload any of the video, it is not missed by you. So thanks for watching the video.